A digital signal is a physical signal that is a representation of a sequence of discrete values, for example of an arbitrary bit stream, or of a digitized analog signal. The term digital signal can refer to either of the following: any continuous time waveform signal used in digital communication, representing a bit stream or other sequence of discrete values, a pulse train signal that switches between a discrete number of voltage levels or levels of light intensity, also known as a line-coded signal or baseband transmission, for example a signal found in digital electronics or in serial communications, or a pulse code modulation representation of a digitized analog signal. A signal that is generated by means of a digital modulation method, to be transferred between modems, is in the first case considered as a digital signal, and in the second case is converted to an analog signal. Waveforms in digital systems. In computer architecture and other digital systems, a waveform that switches between two voltage levels representing the two states of a Boolean value is referred to as a digital signal, even though it is an analog voltage waveform, since it is interpreted in terms of only two levels. The clock signal is a special digital signal that is used to synchronize digital circuits. The image shown can be considered the waveform of a clock signal. Logic changes are triggered either by the rising edge or the falling edge. The given diagram is an example of the practical pulse, and therefore we have introduced two new terms that are: rising edge, the transition from a low voltage to a high voltage; falling edge, the transition from a high voltage to a low one. Although in a highly simplified and idealized model of a digital circuit we may wish for these transitions to occur instantaneously, no real-world circuit is purely resistive and therefore no circuit can instantly change voltage levels. This means that during a short, finite transition time the output may not properly reflect the input, and indeed may not correspond to either a logically high or low voltage. Logic voltage levels. The two states of a wire are usually represented by some measurement of an electrical property. Voltage is the most common, but current is used in some logic families. A threshold is designed for each logic family. When below that threshold, the wire is low, when above high. Digital circuits establish a no-man's area, or exclusion zone that is wider than the tolerances of the components. The circuits avoid that area, in order to avoid indeterminate results. It is usual to allow some tolerance in the voltage levels used. For example, 0 to 2 volts might represent logic 0, and 3 to 5 volts logic 1. A voltage of 2 to 3 volts would be invalid, and occur only in a fault condition or during a logic level transition. However, few logic circuits can detect such a condition, and most devices will interpret the signal simply as high or low in an undefined or device-specific manner. Some logic devices incorporate Schmitt trigger inputs whose behavior is much better defined in the threshold region, and have increased resilience to small variations in the input voltage. The levels represent the binary integers or logic levels of 0 and 1. In active high logic, low represents binary 0 and high represents binary 1. Active low logic uses the reverse representation. See also, digital signal processing, Neustad-Euroshannon sampling theorem, Hitakura-Euroshannon interpolation formula, intersymbol interference in digital communication.